Hello everyone. In this video we will solve Mathematics Paper 2 Variant 1 for October-November 2017. So let's start with question number 1. Jasmine earns $12.50 for each hour she works. She works 38 hours each week. She is given a pay raise of 6%. Calculate the total amount Jasmine earns each week after the pay increase. So first we need to calculate her pay after the 6% increase. So we can say hourly pay after the increase. So there's a 6% increase. So that means it is 106% of the pay that was before the increase, which was $12.50. So her pay after the increase is 106% of $12.50. So this is 106 over 100 multiplied by $12.50. So 106 divided by 100 into 12.50. So this is 13.25. Now we need to calculate the pay for each week after the increase. So weekly pay after the increase would be the new hourly rate, which is $13.25 multiplied by the number of hours she works in each week, which is 38. So 13.25 multiplied by 38 is 503.5. So this will be 503.5. The next part is Abdul earns $525 each week. He moves to a new job where he earns $462 each week. Calculate the percentage reduction in his earnings in his new job. So to find the percentage reduction, first we need to find the decrease in pay. So decrease in salary is 525 minus 462. So this is $63, which is the decrease in salary in dollars. Now we need to find the percentage decrease. So percentage decrease or percentage reduction will be the decrease in dollar amount, which is 63, divided by the original salary before the decrease, before he switched the job, which is 525, and then multiplied by 100. So 63 divided by 525 multiplied by 100, which is 12%. Part 3 is Maria is given a pay increase of 3%. After the pay increase, she earns $2,472 each month. Calculate her monthly pay before the pay increase. So let's say let the monthly pay before the increase. So before the increase equal to X. And then she receives a 3% increase. So then pay after the increase will be, so there's a 3% increase, so that means 103% of the salary before the increase, which was X. So this is 103 divided by 100 multiplied by X, which is 1.03X. So this is the salary after the increase, and we know that this salary is $2,472. So 1.03X will equal 2,472. So X will be 2,472 divided by 1.03. So this is 2,400. So X is the monthly pay before this increase. So that's what we need to calculate. So your answer here will be $2,400. Part B is the exchange rate between dollars and pounds is this. The exchange rate between euros and pounds is this. Dan changes 520 euros into pounds. He spends 260 pounds and then changes the rest into dollars. Work out how many dollars he receives. So first we need to calculate how many pounds does he get when he changes 520 euros to pounds. So you have euros ratio pounds. So the exchange rate between euros and pounds is 1 euro is 0.74 pound, and Dan changes 520 euros to pounds, so let's call it X. So since these are directly proportional, the more euros you have, the more pounds you will get after the conversion. So we simply cross multiply here to get the equation. So X will be 520 into 0.74. So 520 into 0.74. So he gets 384.80 pounds after he converts 520 euros. And then we need to calculate how many pounds left after, so how many pounds are left after spending. So he spends 260 out of these. So the amount left will be 384.80 minus 260. So this minus 260 will be 124.8 pounds are left with him. He then converts, he changes the rest, which is 124.8 into dollars. So we need to work out how many dollars he receives. So now we need to convert these into dollars. So let me actually write it the other way. Pound ratio dollars. The exchange rate is $1 is 0.65 pound. So 0.65 pound here, ratio $1. And now you're converting 124.8 pounds into, let's call them Y dollars. Again, we will cross multiply to form our equation. So 0.65y will equal 124.8 and y will equal 124.8 divided by 0.65. So this is $192 that he will receive when he converts 124.8 pounds into dollars. So this is what you need to calculate. So your answer here will be 192. So basically, he had 520 euros. He converted them to 384.80 pounds. He spent 260 out of these 384.8 pounds, and he was left with 124.8 pounds, which he then converted to dollars to get $192. Question 2 is, Sunil recorded the lengths in minutes of the 150 phone calls he made in 1 month. His results are summarized below. So there were 35 calls that were between 0 and 5 minutes long. 42 calls were between 5 and 10 minutes long, and so on. Calculate an estimate for the mean length of the call. So to calculate the mean length, since these are classes, class intervals 0 to 5, 5 to 10, I will need to find the mid values of these intervals. So let me write down another row for mid value of these intervals. So let's call that mid value x. So here the mid value will be 0 plus 5 divided by 2, which is 2.5. Here the mid value will be 7.5. Here it will be 15. This one will be 25. This is 40. And this is the frequency f. And then we also need to find, I'll write down another row, which will be the product of frequency multiplied by the mid value, which is x. So f times x. So basically I'm multiplying these values, this multiplied by this, then this multiplied by this. So first here I will multiply 35 into 2.5, which is 87.5. So 87.5, then 42 times 7.5 is 315. Then here 30 times 15 will be 450. 28 times 25 is 700. 15 times 40 is 600. Now our mean will be simply sigma fx divided by sigma f. So sigma fx means you find the sum of all these products. So this is 87.5 plus 315 plus 450 plus 700 plus 600 divided by the sum of all the frequencies, 35 plus 42 plus 30 plus 28 plus 15. And we already know the total frequency is 150 because this table is for 150 calls. So if you add all of these frequencies, you will get 150 here in the denominator. So let's add these up. 87.5 plus 315 plus 450 plus 700 plus 600. So this is 2152.5 divided by 150. So this divided by 150 is 14.35. So 14.35 minutes is your mean value. So your mean duration of call for all these calls is 14.35 minutes. Part B is on the grid below, draw a histogram to represent this data. So on the y-axis, you have frequency density. So let me add another column here, or in fact, so let's see. I have these. So let me just erase this now since we have already calculated these. And let me add a row here for frequency density because that's what we need to calculate to draw our histogram. So frequency density is frequency divided by the interval length. So interval length here is 5 minus 0, which is 5. So 35 divided by 5 will be 7. Here 42, again interval length here is 10 minus 5, 5. So 42 divided by 5 is 8.4. So this is 8.4. 30 divided by this interval length is 20 minus 10, which is 10. So 30 divided by 10 is 3. Again here the interval length is 30 minus 20, which is 10. So 28 divided by 10 is 2.8. Here the interval length is 50 minus 30, which is 20. So frequency 15 divided by interval length, which is 20, will give me 0.75. So this here will be 0.75. So now I have all the frequency densities and I can draw the histogram. So our maximum value is 8.4. So if we look at this y-axis, we can represent 1 centimeter by value 1. So this will be 2, 3, 4, 5, 6, 7, 8, and 9. So our first interval is 0 to 5 and our frequency density is 7. So this is 5 here and this is 7. So my histogram will be like this up till 5 and then down here. The next value is 8.4 for 5 to 10. So 8.4 is this 8, 8.2, 8.4 and up till 10. So this will be like this. The next value is 3 for 10 to 20. So 10 to 20 and then 3 up till this point. So let's draw a straight line here and then down here. The next is 20 to 30 and your frequency density is 2.8. So 20 to 30 and 2.8 will be one small block down from 3. So this is 2.8 and then up till 30. And the last one is 30 to 50, which is 0.75. So this is 0.2, 0.4, 6, 8. So 0.75 will be in between 0.6 and 0.8. So this one here and up till 50. So this will be your histogram for this part. The next part is find an estimate for the percentage of Sunil calls that were longer than 25 minutes. So this percentage will be a number of calls that are, so let's call this percentage that we need to calculate, number of calls that are greater than 25 minutes in length divided by the total number of calls. So divided by total number of calls into 100. So this will be the percentage of total calls that are longer than 25 minutes. So if we look at our table, how many calls are longer than 25 minutes? These 15 are definitely longer than 25 minutes because the frequency 15 here represents the interval which of calls which are between 30 and 50 minutes long. So definitely the calls that are between 30 and 50 minutes long, they are longer than 25 minutes. And then if you look at this class here, between 20 and 30 minutes, you have 28 calls. But you are interested in calls that are longer than 25 minutes. So your class interval is 20 till 30 minutes and you have 28 calls. So 25 is right in the middle, right? So you're interested in only calls that are greater than 25. So since the question asks you to find an estimate, what we can do is we can assume that since there are 28 calls in this full interval between 20 till 30, we can say for half of these, since 25 is in the middle, we can say that half, which is 14, half of calls are between 20 and 25, and the other half are between 25 and 30. So this gives you the total interval 20 to 30, which is 28 calls. Since 25 is in the middle, so we can assume that half of the calls are in this interval between 20 and 25, and the other half are between 25 and 30. So now you have 14 calls here which are greater than 25 minutes plus this 15 which are definitely greater than 25 minutes because here the interval is 30 to 50 minutes. So you will add these two. So number of calls that are greater than 25 minutes in length is 14 plus 15. 14 by assuming that half of these 28 are here and half of these are above 25, and then 15 from this class interval. So, and then your total number of calls is 150 here. So this divided by 150 into 100 will give you the percentage of calls that are greater than 25 minutes in length. So you have 29, 15 plus 14 is 29 over 150 into 100. 29 divided by 150 into 100. So this is 19.3% up to three significant figures. So this will be your final answer. Question number 3 is the diagram shows the positions of three towns A, B, and C. B is due north of A, and the bearing of C from A is 220 degrees. This length is 25 kilometers. This is 38 kilometers. The first part is find the bearing of A from C. So to find the bearing of A from C, I will draw a line which represents the north of C. So north of C will be this line here. So bearing of A from C will be this full angle. This will be the bearing. And since B is also north of A, so these two lines are parallel because both of these are directed towards the north. So since these two lines are parallel, I can find this angle BAC, this angle here. So this BAC will be 360 degrees minus 220. So 360 minus 220 is 140. So this angle here is 140 degrees. And since these two lines are parallel and this line AC is passing through these two parallel lines, this bearing and this angle BAC, which is 140 degrees, are two interior angles for these two parallel lines. And using the property of interior angles, that they should sum up to 180 degrees. So let me call this bearing X. So X plus 140 should equal 180 because these are two interior angles of these two parallel lines. So X will be 40 degrees. So your answer here will be 040 degrees, which is this bearing of A from this point C. The next part is show that BC equals 59.4 kilometers, correct to three significant figures. So now if you look at this triangle ABC, I know two sides, the length of two sides of this triangle. This side is 38 kilometers, this side is 25 kilometers, and then I also know the angle between them is 140 degrees. And I have to calculate the length of the side BC, which is opposite to this angle. So I can use the cosine rule here. So cosine rule will give me BC square, this length square, equals to the sum of the squares of other two sides. So the other side is AC square plus AB square minus 2 times AC times AB into cos of the angle between them, which is angle BAC. So now let's substitute the values here. BC is the only unknown, so BC square will be AC is 38 square plus AB is 25. So 25 square minus 2 times 38 into 25 times cos of angle BAC. BAC is 140. So let's calculate this. 38 square plus 25 square minus 2 into 38 into 25 into cos of 140. So BC square is equals to 3524.484442, and then if you take the square root of this, so BC is 59.367, and then if you write it up till three significant figures, 1 2 3, this 3 will be rounded up to 4, which will give you 59.4 kilometers, and that's exactly what you have to show. The next part is calculate the bearing of C from B. Bearing of C from B. So let me draw the north line here. So if I draw north of B, which will be this line, this is also the north. And then bearing of C from B will be this. In fact, let me draw it a little bit wider. So this full angle up till this point. This is the bearing of point C from point B. But since B is north of A, this is a straight line, AB, and this red line that I've drawn, which is the north, this is a full straight line. So that means up till this point, this angle is 180 degrees. So if I can calculate this inner angle, I can add this green angle to this 180 to get this full angle, which will give me the bearing of point C from point B. And for this, I can use the sine rule. I know this side, this angle is 140, and the side opposite we have shown in the previous part, this side is 59.4. And this is the unknown angle. Let's call this Y, or angle CBA. Let's leave it at CBA. So this angle CBA, and the side opposite is 38 kilometers. So I can form an equation using the sine rule here. So using the sine rule, this will give me sine of angle CBA over the length which is opposite this angle, which is AC, equals to sine of angle BAC, sine of angle BAC divided by the side which is opposite this angle, which is this length BC. So let's substitute the values. Sine CBA is unknown, divided by AC is 38, equals to sine BAC. Sine BAC is sine of 140, divided by BC is 59.4. From this we can find the angle. So let me bring this down. So from this, let's calculate this. Sine of 140 divided by 59.4, and then if I take this 38 to the other side, I will multiply this answer with 38. So this will give me sine of CBA equals 0.41121, and angle CBA will be sine inverse of this. So sine inverse of this is 24.28. So I can write this 24.3 degrees up till one decimal point. So now bearing of C from B will be 180 plus 24.3, because as I mentioned earlier, this red angle is the full bearing. So this green angle here is 24.3. So let me write this here, 24.3 degrees. So this is 180, this is another 24.3. So the full red angle, which is the bearing, is 180 plus 24.3. So this here will be 204.3 degrees. So your answer here will be 204.3. Question 4 is Adam has a bag containing 9 balls numbered from 1 to 9. Adam takes a ball at random from the bag and replaces it. Find the probability that the ball has an odd number. So you have 9 balls, one numbered 1, 2, 3, 4, 5, 6, 7, 8, and 9. So you pick one ball. What is the probability that you will get an odd number? So how many of these numbers are odd? 1 is odd, 3, 5, 7, 9. So 1, 2, 3, 4, 5. 5 numbers are odd out of the total 9. So your probability of picking a ball with an odd number is 5 over 9. So the next part is Adam takes a ball from the 9 balls in the bag, notes the number, and replaces it. That means he places it back in the bag. He then takes a second ball from the bag and notes the number and puts it back. Replaces it means he puts it back. Work out the probability that both numbers are odd. So that means you need to find the probability that you get an odd when you pick the first one and you pick another odd number when you pick the second ball. So since you are replacing it, that means your bag will always have the 9 balls inside whenever you're picking it. When you pick the first time, you will have all the 9 balls, and then you pick the second time, again you will have the all the 9 balls, since you put the ball back into the bag after you pick it. So what is the probability that both numbers are odd? So what is the probability when he picks the first one? It is odd. There are 5 numbers that are odd: 1, 3, 5, 7, 9. So picking the first one odd is 5 over 9, and then and means you will multiply, and then you put the ball back again, ball back into the bag, and then you're picking it again. So again you have the same probability of picking the odd number the second time: 1, 2, 3, 4, 5. So each time the probability of picking an odd number is same. The first time you have the probability 5 by 9, and Then when you're picking the second ball, again you have the same probability, 5 by 9. So odd and odd will be 5 by 9 multiplied by 5 by 9, which is 25 over 81. So 25 over 81. Work out the probability that one number is odd and the other is even. So you have to find probability that one is odd and other is even. So how can you get one odd, one even? So that means when you pick the first one, you get odd, and when you pick the second one, you get even number. Or probability that you get even the first time and odd the second time, because the question doesn't mention any order. It says that you have picked two balls, one is odd, other is even. So you can have a combination that the first one that you picked is odd and the second one you picked is even, or you have the probability that the first one is even and the second one is odd. So you will add these two probabilities. So what is the probability that you will get odd and then even? So again, even numbers, and I can mark them odd. These are, so these, first I'll mark the odd numbers, 7 and then 9. And then you have these even numbers. So what is the probability that you pick odd and even? And remember, you are doing replacement. That means when you pick the ball, you put it back in the bag and then pick the second one. So you don't have to remove any balls for your calculating the second probability. So let's look at this one, probability of odd and even. So what is the probability that you pick an odd ball? 1, 2, 3, 4, 5 are odd. So this is 5 over 9. And what is the probability that you pick an even? How many even balls do you have? 1, 2, 3, 4. So the second is 4 by 9. And remember, you're not subtracting anything. You still have 9 balls in the second attempt, because when you pick the first one, you put it back in the bag. Then you pick the second one. So in the second, when you're picking the second ball, you also have the 9 balls, all the 9 balls in the bag. So probability of odd is 5 by 9, and then picking the probability that you pick an even ball is 4 by 9, because you have 4 even balls, even numbered balls out of the total 9. So this will be this probability, and then you have odd, so you will add, and then what is the probability of picking even? 1, 2, 3, 4. So this is 4 out of the total 9, and then multiplied by probability of picking then odd, 1, 2, 3, 4, 5. So again 5 over 9. So now you will calculate this. This will be 20 over 81 plus 20 over 81. So this will be 40 over 81. So this is the probability that you pick two balls with replacement and you get one odd and other even. So you could get this by this combination. Your first one is odd, second one is even, or this combination where your first one is even and the second one is odd. So the probability is 40 over 81. Part C is Adam now takes two balls from the 9 balls in the bag without replacement. So that means now this time he will not put the ball back into the bag. Work out the probability that the two numbers are either both odd or both even. So you have to find the probability that both numbers are odd or both. So this is, let me write this neatly. Both are odd or both are even. So that means you get probability of getting odd and then again odd, or probability of, you have to find both are even. So this is an or, so that means you will add, you get both odds or you get both even. The first one is even and the second number is also even. So this time this is without replacement. So let's calculate this. So now you're picking the ball out of the bag, what is the probability that first one is odd? So you have 9 balls, and how many odds? 1, 2, 3, 4, 5. So you have 5 over 9, picking the first one that is odd. Then multiplied by, now you're doing it without replacement. So that means you are not putting the first ball back into the bag. So we can cancel out, let's say you pick an odd one. So let me just cancel out this one. You can cancel out anyone. So now you picked an odd one. Your first probability was 5 by 9. And now you're picking the second one. What is the now the probability of getting odd? So how many odds are left? 1, 2, 3, 4. So this will be 4. And how many total balls are left? 1, 2, 3, 4. This one is gone. 4, 5, 6, 7, 8. So 1, 2, 3, 4, 5, 6, 7, 8. So total balls are 8. So this is how you will calculate of getting odd the first attempt and odd in the second attempt without replacement. So that now you decrease the value because you have removed one ball and then you're picking the second one. And then what is the probability of getting even and even? So now we are back to start. Now you're calculating the probability of getting even and even. So let me put this ball back. This one is odd. So now what is the probability of getting the first one even? How many evens do you have? 1, 2, 3, 4. So you have 4 evens out of the total 9. And then you have removed one even ball. So let me cancel out any one of them. You can cancel out anyone. So this even is gone. Now you're picking the second ball. What is the probability that this one will be even as well? So how many evens left? 1, 2, 3. So this will be 3 divided by how many total left? 1, 2, 3, 4, 5, 6, 7, 8 balls left. So this is 3 by 8. So now we need to calculate this. This will be 20 over 72 plus 12 over 72. So this will be 32 over 72. And I can divide both the numerator and denominator by 8. 8 times 4 is 32. 8 times 9 is 72. So your answer is 4 over 9. So this is your probability that you pick 2 balls without replacement and you get either both odd numbers on the 2 balls or both even numbers on the 2 balls that you picked. Question number 5, part A, you have to solve this equation. So I can cross multiply. So this y will be multiplied here and this will be here. So I will get y into, so let me actually, so this goes here and this goes here. So y multiplied by y plus 5 equals to 2 multiplied by 2y plus 3. So this will be y square plus 5y equals to 4y plus 6. And then if I take everything to the left side, I will get y square plus y minus 6 equals to 0. So there, this is minus 6, this is plus 1. So if I multiply this minus 6 with this coefficient of y square, I get minus 6. So I need two factors of 6, which I subtract to get this middle number, which is 1. So coefficient of y is 1. So 6 has factors 3 and then 2. So yeah, I can write this y square plus 3y minus 2y. I subtract them because this was negative 6. The product of this constant multiplied by this coefficient of y square, which is 1 here, is minus 6. So since it's a minus sign, I will subtract the 2 and then minus 6 equals to 0. Y, I'll take common y here, y into y plus 3. I'll take minus 2 common here, I'll be left with y plus 3. So if I continue up here, I'll get y plus 3 times y minus 2 equals to 0. So y equals to minus 3 or y equals to 2. So minus 3 or 2. Make t the subject of this formula. So if I take this 2 minus t to the other side, it will be multiplied here. Get 4t plus 1. If I open the bracket, I will get minus 2p minus tp equals to 4t plus 1. Then I'll take this tp to the other side, bring 1 here. So I'll have 2p minus 1 equals to 4t plus tp. 2p minus 1 equals, I'll take t common here. So I'll have 4 plus p. And then if I bring this 4 plus p here, I'll have 2p minus 1 over 4 plus p equals to t. So then t equals to 2p minus 1 over 4 plus p. 2p minus 1 over 4 plus p. Part C is simplify fully. So I can factorize both the numerator and denominator. So again, I'll multiply this plus 8 with this 3. So 8 times 3 is plus 24. So now I'm looking for factors of 24, which if I add, I should get minus 14. So the two factors are 12 and 2. 12 times 2 is 44. 12 plus 2 is 14. Since this is negative, I'll add them in the negative. So 3x squared minus 12x minus 2x will give me minus 14x plus 8 over. In the denominator, I can use the formula a square minus b square is a plus b into a minus b. So this here is x square minus 4 square. And then let's continue. I will take 3x common, x minus 4, and then I'll take minus 2 common, and I'll be left with x minus 4 here as well. And then in the denominator, I'll use this formula. I'll get x plus 4 into x minus 4. And in the numerator, I can take x minus 4 common into 3x minus 2 over x plus 4 into x minus 4. This x minus 4 and this x minus 4 will cancel out. And then I'll be left with 3x minus 2 in the numerator and x plus 4 in the denominator. So 3x minus 2 over x plus 4. Question number 6 is A, B, C, D are points on the circumference of the circle O. AC is the diameter and AC is parallel to ED. AC and BE intersect at this point F. These two angles are 52 and 68. Find angle ACB. So angle ACB is this angle. And since this is the diameter, this angle ABC will be 90 degrees because this is an angle in semicircle or angle subtended by the diameter. So if I look at this triangle ABC here, ABC, this angle is 90. And then this angle is 52. And this is the angle that we need to find, angle ACB. So ACB plus 90 plus 52 will be 180. So 90 plus 52 is 142. Then 180 minus 142 is 38. So your angle ACB is 38 degrees. So this angle here is 38. Part 2 is find angle AEF. Give a reason for your answer. So angle AEF is this angle here. So now if you look at angle ACB and angle AEF, they are angles in the same segment because they are subtended by this same arc. So this arc forms this angle at the circumference, and this also forms this angle here at the circumference. So angles in the same segment are equal. So AEF will be equal to angle ACB. So this is also 38 degree because angles in same segment are equal. So the next part is find angle CDE. So let me just erase this. This is 38. So angle CDE is this angle. So now if you look at this quadrilateral BCDE, so BCDE, so this is a cyclic quadrilateral, and these opposite angles should sum up to 180 degree. So CDE plus 68 should equal 180. So angle CDE plus 68 should equal 180 degrees. So this will give you CDE will be 180 minus 68, which is 112 degrees. So your answer here will be 112. The next part is find angle BCD. So let me just erase this. So we just calculated this one. Angle CDE was 112. So this here is 112. Now the angle that we need to calculate is BCD. BCD is this full angle. We know part of this angle is 38. So if I can calculate this angle, angle FCD, I can add angle FCD to 38 to get this full angle BCD. Now if you look, AC, this line is parallel to ED, and this line CD is passing through these two parallel lines. So that means this red angle and this 112 degrees are interior angles of these two parallel lines. So I can calculate FCD. So FCD plus this 112. These are interior angles of two parallel lines, so they should sum up to 180 degree. So angle FCD will be 180 minus 112, which is 68. So this angle here is 68 degrees. So angle BCD will be 68 plus 38. So BCD will be equal to 68 plus 38, which is plus 38, 106. So this angle here is 106 degrees. So let's move on to the next part. Part B is work out the size of the largest angle in the pentagon. So for this, first we need to calculate the value of x. We can use the property that sum of all interior angles of a pentagon. So let's first calculate the sum. Sum of all angles should be equal to n minus 2 into 180, where n is the number of sides. So pentagon has 5 sides. 5 minus 2 into 180, which is 3 times 180. 3 into 180 will be 540. So now if I sum all of them, which is, let's start from here, x plus 3x plus 124 plus 2x plus 2x should equal 540. 2, 4, 3, 7, 1, 8. So this is 8x equals to, if I take this 124 to the other side, I will get 540 minus 124, which is 416. So x will be 416 divided by 8. So this is 52. The value of x is 52, which is the largest angle for if you are looking at the angles which include this x variable. So certainly 3x will be the largest here. So let's calculate this angle, which is 3x. So 3x will be equal to 3 into 52. So 3 into 52 is 156. So this angle here is 156. This is x, which will be 52. So we don't need to calculate these because these will be certainly smaller than 156. So the largest angle here is this one, which is 156. Part C is the angles in the quadrilateral are given correct to the nearest degree. So your degree of accuracy is, so degree of accuracy is 1 degree, its nearest degree. So your error will be 1, your degree of accuracy 1 divided by 2. So to calculate the error, you always divide the degree of accuracy by 2. So your error is 0.5. So you have to find the lower bound for the value of y. So y is this angle here. So let me mark these angles A, B, C, right? So since this is a quadrilateral, so y plus A plus B plus C, all these angles should sum up to 360 degree. So to calculate y, I'll take all of these to the other side. So y will be 360 minus A minus B minus C. So now we have to find the lower bound of y. So that means I have to find the minimum possible value of y. So how can I find the minimum possible value of y? Since I'm subtracting these numbers from 360, so I'll subtract the upper bound so I get the smallest number. So if I subtract the lower bounds, I will be subtracting a smaller number, so I'll get a larger value of y. So that's why I have to subtract maximum possible number out of this 360 so that I'm left with the smallest possible value of y. So lower bound of y will equal 360 minus upper. So I'm just saying upper bound. So upper A means upper bound of A minus upper bound of B minus the upper bound of C as well. So this will give me the lowest value here. So let's continue here. So lower bound of y will be 360 minus upper bound of A. So A is 65. Error is 0.5. So I will add the error to get the upper bound. So this will be 65.5 minus upper bound of B will be 131.5. Upper bound of C will be 57.5. So this will be 360 minus 65.5 minus 131.5 minus 57.5. So your answer here for the lower bound of y is 105.5 degrees. 105.5 degrees. Question 7 is the points 4 minus 3 and 0 5 lie on the line L. Find the equation of line L. So you have the 2 points here. So your formula for the equation is y minus y1 equals to the gradient, which is y2 minus y1 over x2 minus x1 into x minus x1. So I can call this x1 and y1 coordinates and this as x2 and y2. So now let's substitute the values here. So this will become y minus y1, which is minus 3. So this will be y plus 3 equals to y2 minus y1 will be 5 plus 3 divided by x2 minus x1 will be 0 minus 4. 0 minus 4 into x minus x1 is 4. So this will be 5 plus 3, 8. 8 divided by 4 will be 2. So this will be negative 2. So y plus 3 equals to negative 2 into x minus 4. So let me continue here. So if I open this bracket, I will get y plus 3 equals to minus 2x plus 8. And if I take this 3 to the other side, I will get y equals to minus 2x. 8 minus 3 will be plus 5. So this will be your equation, y equals to minus 2x plus 5. The next part is the line M is parallel to line L and passes through this point. Find the equation of line M. So since the line M is parallel to line L, the gradient will be the same as the gradient of line L, which is minus 2. So you have gradient of line M will be equal to minus 2. So now you can find the equation y minus y1 equals to gradient M times x minus x1. So y minus y1, so let's call this x1 and y1. So this will be y minus 3 equals to gradient is minus 2 into x minus x1. So this minus and this minus will become plus and 2. So now if I open this bracket, I will get minus 2x minus 4. If I continue here, if I take this 3 to the other side, I will get y equals to minus 2x minus 4 plus 3 will be minus 1. So y equals to minus 2x minus 1. Part B is the table shows some values of x and the corresponding values of y for y equals to x plus 3 over x minus 3. Part 1 is complete this table. So our missing value here is for when x equals to 6. So if I substitute x equals to 6 here, I will get 6 plus 3 over 6 minus 3. So this will be 6 plus 1 by 2 minus 3. So 6 plus 1 by 2 is 0.5 and then minus 3. So you get 3.5. So here y equals to 3.5. The next part is using a scale of 2 to 1 on both axes, draw horizontal axis for 0 to 7 and vertical axis for y 0 to 4. And then you have to draw the graph of this equation for x greater than equal to 0.5 and less than equal to 6. So you have to use 2 centimeter to represent 1 unit. So let's start with the x values here. So if I have x value 0 here, then 1, 2, 3, 4, 5, 6, 7. So that means my x value will be 0 here. So that means this line here will be my y-axis. So let me draw my y-axis here. So this will be my y-axis. And then for y values, you have 0 till 4. So if I start from y values 0 here, 0, 1, 2, 3, 4. So my x-axis will be this line because my y of 0 is also starting from this point here. So this will be my origin. So let me draw the x-axis here. So this is my 0 value, 1, 2, 3, 4, 5, 6, and 7. And similarly, 2 centimeters representing 1 unit on the y-axis as well, up till 4. So now you have to draw the graph of this equation. So you have the table here. First value is 0.5 and 3.5. So 0.5 and 3.5 will be this value. Then you have 1, 1. 1, 1 will be this. Then you have 1.5 and 0.5. 1.5 and 0.5 is this. Then you have 2 and 0.5. 2 and 0.5 will be this. 3 and 1. 3 and 1 will be this. 4 and 1.75. 4 and 1.5, 1.6, 1.7, and 1.75 will be in the middle of this small block here. 5 and 2.6. 5 and 2.5 and 2.6 is this. And then you have 6 and 3.5. 6 and 3.5 will be this value here. So this is the plot. Now we will join them to draw a smooth curve. So let me draw this. Oops. So this will be our curve for y equals to x plus 3 over x minus 3. The next part is by drawing a tangent, estimate the gradient of the curve at point 1 and 1. So 1, 1 is this point. So I will use my ruler here to draw a straight line which will just touch the graph at this point 1 and 1. So let me align my ruler here so that just touches the graph at this point x equals to 1 and y equals to 1. Maybe a little bit more. Okay, this looks good enough. So now we can draw a straight line here which just touches the graph at x equals to 1 and y equals to 1. So now we can take any 2 points. So let's take this one. So this is, it's in the middle of this small block, so I can call it 1.55 and y value is 0. And then here I'll take this point. So the x value is 0.4 and the y value is 2. So now we can calculate the gradient. So the gradient would be, m gradient would be y2 minus y1, so 0 minus 2 over 1.55 minus 0.4. So this will be minus 2 over 1 point. So 1.55 minus 0.4 is 1.15. So minus 2 divided by 1.15. So your gradient is minus 1.74 up till 3 significant figures. So minus 1.74. The next part is use your graph to solve the equation x plus 3 over x equals to 5. So if you look at the equation of the curve is y equals to x plus 3 over x minus 3. So let me just write it down here. The equation of the curve is y equals to x plus 3 over x and minus 3. So if I look at this equation, I would like to convert it into this form so that I can use my graph for this equation that I have drawn. So it looks pretty similar, only minus 3 is missing here. So if I subtract 3 on both sides of the equation, so I will get x plus 3 over x minus 3 here, and then 5 minus 3 here as well. So now this is the same equation as the equation of the curve that we have drawn. So x plus 3 over x minus 3 equals to 5 minus 3 will be 2. So that means we have to find the y value when this equation equals 2. So that means if you want to look at another way, this is actually, this whole thing is y. So I can substitute this with y equals to 2. So basically I'm looking at the curve or the curve that we have drawn for this equation where the value of this curve is, the y value of this curve is 2 or y equals to 2. So how do we find what are the x values when y value is 2? So we can draw a straight line at y equals to 2. So I'll draw it in green. Oops, a little below. So this is y equals to 2, and this blue curve has y value 2 when x value here is, so this is almost 0.567. So the first value is this one. So this is 0.7, and the other value is this one, which is almost 4.3, I believe. So yeah, this one is 4.3. So when x is 0.7 and when x is 4.3, the y value of this curve or the y value of this equation is 2. So you basically first converted this equation into the equation of the curve that we have by subtracting 3 on both sides. So now you have this equation, and then you're looking for y value, which is 2. So you draw a line at y equals to 2 and see what are the x values. So for if you substitute x equals to 0.7 or x equals to 4.3, you will get y equals to 2. So since we are reading them from the graph, you might not exactly get y equals to 2, but you'll get a value which is very close to y equals to 2. So for these two values of x, basically, you get y value 2. So your answer here will be 0.7 and 4.3. So question 8 is the diagram shows a solid A which is made from a hemisphere joined to a cone of equal radius. The hemisphere and cone each have radius 6 centimeter. The total height of the solid is 18. Show that the slant height x centimeter of the cone is 13.4, correct to one decimal place. So the radius of the hemisphere is 6. So if this is 6 and the radius of the cone is also 6. So that means this length here will be 6 as well. And the height of the cone will be this full height 18 minus this height 6. So this height here will be 12, or this perpendicular height of the cone will be 12 as well. So since this is a right angle triangle, I can use the Pythagoras theorem. I will get x square equals to 12 square plus 6 square. So 12 square plus 6 square. So x square equals to 180. So x will be square root of 180, which is 13.4 centimeters, correct to one decimal place. So you have shown that x is 13.4. Part B is calculate the total surface area of solid A. So surface area of solid A will be equal to the surface area of this hemisphere plus the curved surface area of the cone. So only the curved surface area, not the base, because base is not part of the surface area of the full solid. This is, I think, hollow inside, so there will be no base as such uh, for this cone. So this cone is attached to this hemisphere. So the surface area of this full solid will be the curved surface area of the cone plus the outer surface area of this hemisphere. So this will be surface area of hemisphere plus surface area of cone. So what is the surface area of hemisphere? Surface area of sphere is 4 pi r square. So since this is a hemisphere, you will divide by 2. So for hemisphere, you will get 2 pi r square. So this will be 2 pi r square plus the curved surface area of the cone is pi r l plus pi r l. So now the radius is 6 for this hemisphere. So this will be 2 pi into 6 square plus pi into, again, the radius of the cone is also the same as the radius of hemisphere. So this will be 6 into L, which is the slant height, which is x that we calculated as 13.4. So into 13.4. So now let's calculate this. 2 into pi into 6 square plus pi into 6 into 13.4. So this is 478.778. So if you want, you can write it up till 3 significant figures. So this will be 479 centimeter square. So 479. Part C is calculate the volume of solid A. So volume of solid A will be similar to how we calculated the surface area. It will be the volume of the full solid will be the volume of this cone plus the volume of this hemisphere. So again, volume of hemisphere plus the volume of cone. So what is the volume of hemisphere? Volume of a sphere is 4 by 3 pi r cube. So for hemisphere, you will divide it by 2. So for hemisphere, it will be 2 by 3 pi r cube. And volume of cone is 1 by 3 pi r square h. So volume of hemisphere 2 by 3 pi r cube plus volume of cone is 1 by 3 pi r square h. So again, the radius is 6. So 2 by 3 into pi into 6 cube plus 1 by 3 into pi into radius of cone is also 6. So 6 square into h is the perpendicular height of the cone, which is 12 into 12. So now let's calculate this. 2 over 3 into pi into 6 power 3, 6 cube. And then plus 1 by 3 pi r square h plus 1 over 3 into pi into 6 square into 12. So this is 904.778, which in three significant figures will be 905 centimeter cube. So this is the volume of solid A. Part D is solid A is one of a set of three geometrically similar solids A, B, and C. The ratio of the heights of solid A, solid B, and solid C is 2:6:1. Calculate the surface area of solid B correct to three significant figures. So since these are similar solids, we can use the property that the ratio of their surface areas will be the ratio of the square of their heights. So that means here height of B squared divided by height of solid A square will equal area of solid B divided by area of solid A. So this is the property of similar solids, that the ratio of their areas is equal to the ratio of the square of their heights, or like when one like corresponding side. So here we are given the heights. So now let's substitute the values here. So height of B is 6 square divided by height of A is 2 over 2 square equals to area of B divided by area of A is 479. 479. So this will give you area of B equals to, so I'll take this 479 there. So first let me calculate this. 6 square is 36 divided by 2 square is 4. And this multiplied by 479. So this is 4,311 centimeters square. But the question asks you to write it in three significant figures. So 1, 2, 3. So this last one will be rounded down to 0. So 4,310 centimeter square will be your answer in three significant figures. So these are the three figures, and then 0 is not a significant figure. The next part is calculate the volume of solid C correct to three significant figures. So similar to how we use the square of the ratio of the square of their heights, for volume we take the ratio of the cube of their heights. So here this will be height of solid C. Now since we are dealing in volume, we will take the cube divided by height of solid A and then cube. This will equal the ratio of their volume. Volume of C divided by volume of A. So what is the height of C here? C is the last one, so 1. So this will be 1 cube divided by height of A is the first one, which is 2. 2 cube equals to volume of C divided by volume of A that you calculated was 905. So this will be 905. So I'll take this 905 there. So this will be 1 over 8. 1 over 8 multiplied by 905 will be the volume of solid C. So this will be 905 divided by 8. So volume of C is 113.125. Again, the question asks you to give the answer in 3 significant figures. So 1, 2, 3. The next value is less than 5. So this will be simply 113 centimeter cube in 3 significant figures. Question number 9 is a pump takes 12 minutes to add 3000 liters of water to a pond. How long will it take the same pump to add 1750 liters of water to a pond? So we can use, I'll show you two methods. One is the ratio and other one is the unitary method. So first let's use the ratio method. So you have minutes, ratio, liters. So you pump takes 12 minutes to add 3000 liters. So 12 minutes for 3000 liters. And then how long will it take? So let's take X minutes for 1750 liters. So since they are directly proportional, because if you increase the number of minutes, you will add more liters of water to the pond. So I will cross multiply them to form my equation. So this will be 3000x equals to 1750 into 12. So 1750 into 12 is 21,000. So x will be 21,000 divided by this 3000, which is 7. So your answer is 7 minutes. Or you can use the unitary method as well. So 3000 liters take how many? 12 minutes. So 1 liter will take 12 over 3000 minutes, and then 1750 liters. So this is 1750 liters will take 12 over 3000 into 1750, which is again 7 minutes. So part B is a tank holds 2500 liters of oil. A small pump can add oil to the tank at a rate of X liters per minute. A large pump can add oil to the tank at a rate of X plus 20 liters per minute. Part 1 is write down an expression in terms of X for the number of minutes the small pump takes to fill the empty tank. So let's call that time T small s, where s denotes the small pump. So the time taken by the small pump to fill the tank will be the capacity of the tank, 2500 liters, divided by the rate at which it fills the tank. So it fills the tank at x liters per minute. So this will give you the time in minutes that the small pump will take to fill that tank. So this is it has to add 2500 liters to the tank, and it's adding it at a rate of x liters per minute. So your time will be 2500 over x. Part 2 is it takes 15 minutes longer to fill the empty tank using the small pump than it does with the large pump. Find an equation in x and show that it simplifies to this. So the difference in time is 15 minutes. Small pump takes this much time, so let's calculate how much time the large pump takes. Let's call it TL. So the large pump will take 2500, which is the capacity of the tank, divided by the rate at which the large pump fills the tank, which is x plus 20. And now you're given that the small pump takes 15 minutes longer. So that means time taken by the large pump minus time taken by the small pump is 15 minutes. The difference between the two times is 15 minutes. So then we can substitute the values here. So in fact, it's the other way around. The smaller pump takes 15 minutes longer. So the time for smaller pump is obviously larger because it's filling the tank at a slower rate. So the time taken by the smaller pump is larger minus the time taken by the larger pump is less because it's filling at a higher speed. So it will take less time. So the difference between them is 15 minutes. So TS is 2500 over X minus TL is this equals to 15. So now we can simplify this equation and show it boils down to this. So let's take the LCM here. So X into X plus 20. This will be multiplied by X plus 20 and this will be multiplied by simply this X here equals to 15. So if I open the bracket, I get 2500x plus 2500 into 20, which is 50,000. So 50,000 minus 2500x, and if I open the bracket in the denominator, I get x squared plus 20x equals to 15. So this 2500x minus 2500x cancel out. So 50,000 equals to, I'll take this to the other side. So 15 multiplied by x squared plus 20x. 50,000 equals to, if I open this bracket, I get 15x squared plus 20 into 15, which is plus 300x. Now if I take this 50,000 to the other side as well, I will get 15x squared plus 300x minus 50,000 equals to 0. And then I can take 5 common. I will have 3x squared plus 60x minus 5 ones are 5, 0, 0, 0, 0 equals to 0. And then if I take this 5 to the other side, I'm left with 3x squared plus 60x minus 10,000 equals to 0. So this here is the same value as we have in the question here. So you've shown that it simplifies to this. The next part is solve this equation. Give your answer correct to two decimal places. So I'll use the quadratic formula. So x will be equal to minus b, which is 60 here, plus minus square root of b square, which is 60 square, minus 4 into 3, which is a, and then c is minus 10,000 divided by 2a. A is 3. So let's first find the value inside the square root. So 60 square minus 4 into 3 into minus 10,000. 1, 2, 3, 600. So x equals minus 60 plus minus square root of 123,600 divided by 6. So x equals minus 60 plus square root of 123,600 divided by 6, or x equals to minus 60 minus square root of 123,600 over 6. So let's calculate this first. Square root of this and then minus 60 here and then divide by 6. So here you get 48.59, correct to two decimal places. So you have to find up till two decimal place. So this x value here is 48.59, and this one will be minus 60 minus square root of 123,600 and then divide by 6. So this will be minus 68.59 up till two decimal place. So this is 48.59 and this one is minus 68.59. Part 4 is find the length of time the large pump takes to fill the empty tank? Give your answer in minutes and seconds, correct to the nearest second. So the time taken by the large pump is 2500 divided by x plus 20. So TL is 2500 divided by x plus 20. So now you have to decide which value of x to use. So if you use the negative value here, so minus 68.59 plus 20, so minus 68.59 plus 20 will be, so this 2500 will be divided by minus 48.59. So your value of time will be in negative. So that's not possible, right? Your time value cannot be in negative minutes and seconds. So the time to fill the pump, the time that the large pump takes to fill the pump should be a positive value. So we will use this value of x. So the positive value of x. So this is 2500 divided by x plus 48.59. Oh, sorry, not x plus 48. X is 48.59. So 48.59 plus 20. So 48.59 plus 20 is 68.59. So this will be 2500 divided by 68.59, which is 2500 divided by this 36.448 minutes. So you have 36 minutes. So to convert these 0.448 into seconds, I will multiply it by 60. So minus 36, which are the minutes. So I'm left with these many minutes, 0.44846, the decimal value. And then I will multiply it by 60 to get the number of seconds. So this is 26.9 seconds. So we have to write the answer correct to the nearest second. So correct to the nearest second, 26.9 will be 27 seconds. Correct to the nearest second. So your answer here will be 36 minutes and 27 seconds. So let's move on to the next question. Question number 10, part A, triangle A is shown on the grid. So the triangle A is mapped onto triangle B by a rotation of 180 degrees about point 2 and minus 1. Draw and label triangle B on the grid. So your center of rotation is this point 2 and minus 1, and you are rotating 180 degrees around this point. So let's take each vertex. So let's start with this one here. So how do you rotate? You first connect your point that you want to rotate with the center of rotation. So I will connect it like this, and then you have to rotate it 180 degrees. So you can use a protector, but for 180 degrees it's pretty straightforward. So that means 180 degree rotation will so you'll measure the angle from this side, which connects the center of rotation with the point, and then measure 180 degrees. So your 180 degrees will be this. So you'll end up this way, and then you will go the same distance. So if this distance is 2, you will go another distance which is equal. So this will be 2 blocks as well, and you will end up here. So this point here will be mapped to this point after 180 degree rotation. So let me just erase this arrow here. And then similarly, let me use the ruler here for the next coordinate here. So I'll now rotate this one. I will again connect it with my center of rotation. So an easy way to do this is you can connect and then measure the length. So here the length is about 2.2. So I will double the length. So I will go the same distance on the other side. So I will end up at this point, which is around 4.4. So this is almost 2.25. So this will be 4.5. So I will end up here. So let me show you what I mean. I will draw a line that connects the point that I'm trying to rotate with the center of rotation. Then again 180 degree rotation will lead me to continue in the straight line here. and then I will continue after 180 degrees. So I will end up at this point here. So this point will be mapped onto this one. And then let's do the same for this one. So let me just first connect it with the center of rotation. And then if you look at this, it's 1, 2, 3, 4 blocks down and 1 block to the right. So I will continue, since it's 180-degree rotation, I will continue in the same direction, 4 blocks down and 1 block to the left, to the right. So 4 blocks down and 1 block to the right, I will end up here. So all these lines, so line connecting the image with the center of rotation and the original vertex or the original object connecting with the center of rotation, they will make a 180-degree angle. So if you take any of these points, let's take this, let's call this A. It's mapped onto this A prime, right? So the line, let's call this center O. So OA and OA dash will make this angle, which is 180 degrees. So that's how you will rotate around this point. So let me just erase this, and then I can simply join these 3 points to form my triangle B here. So this will be my triangle B. The next part is triangle A is mapped onto triangle C by the transformation represented by the matrix 3003. Draw and label triangle C on the grid. So once you're given the matrix, you know that you can apply the transformation. So transformation T applied to the object O will give you the image I. So your transformation matrix here is 303, 3003, and now your object is triangle A. So you will take the coordinates of triangle A. So you have first coordinate is this one, which is 1 1. So 1 1. Other coordinate is 2 1. So 2 1. And the third coordinate is 1 3. 1 3. And this will lead you to your image, which is triangle C after the transformation. So let's do this multiplication. This row multiplied by this column will be 3 times 1 is 3 plus 0. So this will be simply 3. Again, 3 times 2 is 6. This will be 0. So this is 6. This row multiplied by this column will give you again 3 here. Then this row multiplied by this column, 0 multiplied by 1 plus 3 times 1. So this will be 3. This row multiplied by this column will give you 0 plus 3, so 3, and 0 plus 9. So these are the coordinates for your triangle C. So let's mark them. 3 3 will be this here. Then you have 6 3. 6 3 will be this. Last one is 3 9. 3 9 will be this. So now let's join these to form our triangle C. So this will be our triangle C. The next part is write down the matrix that represents the transformation that maps triangle C onto triangle A. So this matrix mapped triangle A onto C. Now we are looking for the reverse. We want to go from triangle C to triangle A. So there are two ways to solve this. I'll show you both. So the first one is you can, if you remember your enlargement matrix K00K, this matrix represents an enlargement about the with center of enlargement as the origin 0 0, and your enlargement factor or the scale factor is K. So in this case, when you went from triangle A onto triangle C, you did an enlargement of scale factor 3 with the center of enlargement as the origin. So if you want to go in the opposite direction, that means you will do the opposite enlargement, which will be 1 over 3. So your matrix here will be 1 over 3 0 0 1 by 3. This matrix 3003, which takes you from triangle A onto triangle C, is enlargement with center origin and scale factor 3. So if you want to come back from C to A, then you will uh, do the same enlargement but with the reciprocal scale factor. So your scale factor in that case will be 1 by 3. So once you went from A to C, your lengths increased by a factor of 3. So this was 1, this became 3. So when you want to come back, you have to decrease the length by the opposite scale factor. So your scale factor will be 1 by 3. So once you multiply this length 1 by 3, this length 3 with 1 by 3, you will get the length 1 back, which is of triangle A. So this is the opposite enlargement. So when going from triangle C to A, you will have this matrix. But if for some reason you don't remember that this is the enlargement matrix with scale factor 3 and center of enlargement 0, you can actually calculate this matrix as well. So let me show you how. We will use again the same equation here, that you apply transformation T to an object to get the image I. Now in this case, your object is now triangle C. So transformation T is the matrix that is unknown. So let's call it A, B, C, D, and then multiplied by the object. Object is this triangle C. So let me write down its coordinates: 3, 3, 6, 3, and 3, 9. And it will give you the image. Image is the triangle A that you're mapping onto, and triangle A has this coordinates. So let me write down 1, 1, 2, 1, and 1, 3. Now if I can somehow find the inverse of this matrix, I can multiply it on this side and on this side, and this will cancel out. So I will have this matrix ABCD that I can find easily. But you haven't really studied how to find the inverse of a rectangular matrix. You have studied how to find the inverse of a square matrix. So something like ABCD is a square matrix, a 2 by 2 matrix. You can easily find the inverse of this. So instead of using all three vertices of a triangle, I can pick a pair or like two vertices and use them to find the transformation matrix. And also make sure that the two pairs of coordinates that you use, make sure that they don't give you a determinant of 0, because if you have a determinant of 0, you cannot really find the inverse of a matrix, because when finding the inverse, you do 1 over determinant, and this is 0. 1 over 0 is undefined. So let's pick these two coordinates. So this is 3, 3, this one, and the other one is 6, 3. 6, 3. And these are mapped onto 1, 1 and 2, 1. So these are mapped onto 1, 1 and 2, 1. So I can apply the same transformation matrix to two vertices of this triangle. So I will rewrite it as A, B, C, D, same transformation matrix, multiplied by, now I'm only using two coordinates, two vertices. So the first vertex is 3, 3, x value 3, y value 3. The other one is 6, 3. And these two are mapped onto these two, which are the two vertices of triangle A. So instead of using all three vertices, I can use two vertices so that I have a square matrix here. So 1, 1 and 2, 1. Now I can easily solve this using matrix algebra. So I will find the inverse of this, multiply the inverse on both sides to get the matrix ABCD. So let me find the inverse here. So determinant, first we need to find the determinant. Determinant here will be 3 times 3 minus 6 times 3. So this is 9 minus 18, which is, so 3 times 3 is 9 and 6 times 3, so minus 9 here. So this will be your determinant here. And now let's find the inverse. So inverse will be equal to 1 over determinant, so which is 1 over minus 9 multiplied by the adjugate. So for adjugate, you swap the position of these two. So This will 3 will remain same when you swap the positions and you change the sign of the other two. So this is -6 and -3. So this is your inverse. Now if I multiply the inverse on both sides, so A, B, C, D, and I multiply the inverse here and here. So this will cancel out. I will be left with A, B, C, D here. And then I will have 1, 1, 2, 1 multiplied by -1/9. This inverse here, which is -1/9 into 3, -3, -6, and 3. So let me in fact take this 9 inside so I don't have to do this here. So let me simplify this inverse. If I take this -9 inside, I get -1/3. 3 by 9 is 1/3. I'll get plus 2 by 3 here. If I take this inside, I'll get plus 1 by 3 here and plus 1 -1 by 3 here. So minus minus becomes positive here, and minus 3/9 is -1/3. So this is your inverse. So let me write this down here. -1 by 3, 2 by 3, 1 by 3, and -1 by 3. So now we can multiply this row with this column. So let me actually move this to this side and continue it here. So A, B, C, D, A, B, C, D will equal. So this row multiplied by this column will be 1 multiplied by -1 by 3 plus 2 by 3. This is your first row, first column. Then first row, second column, you will get 2 by 3 minus 2 by 3. So 2 by 3 minus 2 by 3. So this row multiplied by this column, -1 by 3 plus 1 by 3. So -1 by 3 plus 1 by 3. And then this row multiplied by this column will give you 2 by 3 and then -1 by 3. So 2 by 3 minus 1 by 3. And move this here. If I continue here, so this is -1 by 3 plus 2 by 3 will be 1 by 3. 2 by 3 minus 2 by 3 will be 0. -1 by 3 plus 1 by 3 will be 0. 2 by 3 minus 1 by 3 will be 1 by 3. So this is the same matrix that we initially found. So this is another way of doing this. If you can't remember that 3003 represents an enlargement with scale factor 3, you can use this formula here. Let me in fact keep it away. So you can use this formula that you apply a transformation to an object to get the image. So transformation matrix is unknown in this case. Your object is your triangle C. So you have 3 pairs of coordinates for triangle C, and then which maps onto triangle A, which also has 3 pairs of coordinates. So since we do not know how to calculate an inverse of a rectangular matrix, we only know how to calculate the inverse of a 2 by 2 matrix. So instead of taking all 3 coordinates of triangle C, I picked these 2 pairs and the corresponding 2 pairs. So remember, you have to pick the corresponding pairs. 3 by 3, 3 is mapped onto 1, 1. So if you look back here, when you move from triangle C to triangle A, this point 3, 3 is mapped onto this point 1, 1 here. This one. So I picked these two from here and these two from here. So then my equation became ABCD multiplied by this square matrix equals to this square matrix, which represents two vertices of triangle C, and this represents two vertices of triangle A. And now I can easily find the inverse and multiply the inverse here and here. So this will cancel out. I will be left with my transformation matrix ABCD on one side of the equation, and the other side of the equation you will do this multiplication to get the final matrix, the transformation matrix. So this is another way of doing it. It's slightly longer, but In case you forget the enlargement matrix, you can actually do this full calculation to get your answer. So let me bring back my calculator here. Move this here. And let's continue to the next part, which is describe fully the single transformation that maps triangle C onto triangle B. So triangle C is now being mapped onto triangle B. So clearly this is an enlargement because your size has changed. So to find the center of enlargement, what we do is we connect the corresponding points. So if I look at this point, this vertex in C, it is mapped onto this vertex in triangle B. So I will connect these two. So object is being connected to the image. And similarly, this point here is mapped onto this point here in triangle B. So I will again connect the object, which is vertex of triangle C, and it is mapped onto this point here. So this is the point of intersection of these two lines which are connecting the object with the image. So the point of intersection will give you the center of enlargement. So this point is 3 and minus 1.5. And for scale factor, you can simply divide the length in the image. So this length is 1. This length here is 1. And this corresponding length in triangle C is 3. So this is the image over object. So your scale factor is 1 by 3, and it will be negative 1 by 3 because negative sign comes from the position of the image. So the image is on the other side of this center of enlargement. If the image is on the same side, so if triangle B was somewhere here on the same side of the center of enlargement as the original object, then the scale factor is positive. Since the image is on the opposite side of the center of enlargement, your scale factor will have a negative sign. So this will be minus 1 by 3. So your final answer here will be that the transformation is enlargement with center. Center was 3 and minus 1.5. So center is 3 minus 1.5 and scale factor is uh, minus 1 over 3. So your scale factor is minus 1 over 3. So this is the transformation, single transformation that maps triangle C onto triangle B. The next part is the diagram shows triangle PRS. Q is the midpoint of PR. PQ is 6, 3 and PS is 8 minus 2. Find SR. So SR is this. So we can find SR by head to tail rule. So SP plus PR. So SR can be written as SP vector plus vector PR. SP will be simply minus PS. So this will be minus PS. Since PS is in this direction, once you go in the opposite direction, you multiply it with minus 1. And PR will be, since Q is the midpoint, so if PQ is this, I know PQ, I can multiply it by 2. So this will be multiplied by 2 to get PR. So PS plus minus PS plus 2 times PQ is PR. So now let's substitute the values. Minus PS will be minus 8 plus 2 plus 2 times PQ. 2 times PQ will be 6 times 2 is 12 and 3 times 2 is 6. So minus 8 plus 12 will give you 4 and 6 plus 2 will give you 8. So this will be 4 and 8. T is the point on SR such that ST ratio TR is 1:3. So T is some point here such that ST is, so this is 1, and then this length is TR is 1:3. So ST is 1, TR is 3. So that means this full length would be 4 if this is 1:3. So the ratio for this full length will be 4. So the question asks you to find PT. So PT will be uh, PS plus ST. So this will be PS plus ST. So PT here will be PS plus ST, and ST, we know SR, we have calculated this full length, SR is 48. So ST is just 1/4. This is 1, this full length is 4. So ST will be 1/4 of SR. So PS plus ST is 1/4 of this full length SR, because this is 1:3, so full length is 4. So 1/4 of SR here. And now let's substitute the values. So PS is 8 minus 2 plus 1/4 of SR. So if I take this 1/4 inside, 4 divided by 4 will be 1, 8 divided by 4 will be 2. So 8 plus 1 is 9, 2 minus 2 will be 0. So PT will be 9, 0. Question 11 is ABCD is a rectangle. P and Q are points on DC. AQ and BP intersect at R. Prove that triangle ARB is similar to triangle QRP. Give a reason for each statement you make. So since this is a rectangle, that means this line is parallel to this line, and this line AD is parallel to line BC. So since these are straight lines, this angle will be equal to this angle because they are vertically opposite angles. So first will be angle ARB equals angle PRQ. PRQ, because they are vertically opposite angles. Next, if we look at angle RAB, so this angle here will be equal to angle RQP. Why? Because this is a parallel line, these two are parallel line, AB and DC are parallel, and this line AQ is passing through these two parallel lines, and these two green angles are alternate angles. So we can write angle RAB will be equal to angle RQP because they are alternate angles. And similarly, if you look at this angle RBA, so if you look at angle RBA, this will be equal to this angle RPQ. Again, these are two parallel lines, and this line BP is passing through these two parallel lines, and these two red angles are alternate angles. So again, the same property, angle RBA will equal angle RPQ because they are alternate angles. So all three angles are equal. So triangle ARB is similar to triangle QRP because all three angles are same. The next part is in rectangle ABCD, you're given this length is 9, this is 5, these two angles are also given. The first part is calculate AQ. So AQ is this length. So if you look at this triangle AQD, let me draw it separately outside. So this is A, this is D, and this is this point Q. So this angle here is 55, this length here is 5, and this is the hypotenuse. And since this is a rectangle, this angle is 90 degree, this angle is 90 degree here. So this is a right angle triangle. We know this angle, we know this side, we need to find the hypotenuse AQ. So we can use cosine here. So cos of angle DAQ, cos of angle DAQ will be this side AD base over hypotenuse, which is AQ. So if I take this AQ here and bring this here, my AQ, if I make this the subject of the equation, will be AD over cos of DAQ. So AD is 5 and DAQ is 55. So cos of 55. So this will be 5 divided by cos of 55, which is 8.717, and I can write it 8.72 centimeter up till three significant figures. The next part is calculate AR. So AR is this length here. So if you look at this triangle ARB, it is also a right angle triangle. This angle is given as 90 degree. And since this is a rectangle, this full angle is 90. And this angle here will be 90 minus 55. So let's first calculate angle RAB. Angle RAB will be 90 minus 55. So 90 minus 55 will be 35. So this here is 35 degrees. Now, if I draw this triangle outside separately to show it more clearly, this is 90 degree. This here is 35 degree. This length here is 9. So this is A, R, B. So I need to find this length. I know this length is 9. I'm given one angle of this right angle triangle. So I can again use cosine. So cos of angle RAB will be equal to this base, which is AR, divided by this hypotenuse, which is AB. So cos of RAB is 35 degree, AR is unknown, AB is 9. So let me select this and bring it down here. So now from this we can calculate AR. AR will be cos of 35 multiplied by 9 if I take this 9 to the other side. So this gives you AR, which is 7.37 centimeter up till three significant figure. The next part is calculate the area of triangle ARB. So we just calculated this length is 7.37 and we need to find the area of this triangle. So basically the same triangle, now we know this length is 7.37. So I know two sides, I can calculate this perpendicular height of the triangle to calculate the area. So using the Pythagoras theorem, AB square will equal AR square plus BR square, where BR is the only unknown. So AB square will be 9 square plus equals to 7.37 square plus BR square. So let's take this. So let's calculate BR from this. This will be 9 square is 81. I'll take this 7.37 to the other side, so minus 7.37 square. So BR square is 26.6831. So BR will be the square root of this. Square root of this 5.165. So 5.17 centimeter up till three significant figures. So area of triangle ARB will be 1 by 2 into base into height. So 1 by 2 into base is this, and this is 5.17, the height. So 1 by 2 into 7.37 into 5.17. So this will be 1 over 2 multiplied by 7.37 into 5.17. Oh, 5.17. So this is 19.05. So up till three significant figures, this will be 19.1 centimeter square. Calculate the total area of the shaded region in the rectangle. So we already calculated the area of this upper triangle. We only need to calculate the area of this lower triangle, and we can add the two to get the total shaded area. So we already proved that these two triangles are similar. We know that this length AR is 7.37, and we also know that this full length AQ here is 8.72. So this length RQ will be 8.72 minus 7.37. So 8.72 minus 7.37 is 1.35. So this length here, oops, is 1.35. So if you add them two, you will add the two together, you will get this full length AQ, which we calculated in the first part to be 8.72. Now, since these are similar triangles, I can use the property that the ratio of their areas will equal to the ratio of the square of their sides. So I will take two corresponding sides. So let me look back here. So if I take the ratio of this AR over RQ, so AR over RQ, and then take the square equals to the ratio of their areas. So area of AR is the length of this triangle ARB. So this will be area of triangle ARB divided by area of the other triangle, the smaller one that is at the bottom, PRQ. P, oops, RQ. So let's substitute the values. AR is 7.37. So 7.37 divided by RQ is, this was 7.37, this is 1.35. 1.35 and then whole square equals to area of ARB that we calculated in the previous part is 19.1 divided by area of triangle PRQ. So let's first calculate this. 7.37 divided by 1.35 and then square. So this is 29.8035 equals 19.1 over area of triangle PRQ. So if I take this up here and bring this down here, I will get area of triangle PRQ equals to 19.1 divided by this 29.8035. So 19.1 divided by 29.8035. So this is 0.641. 0.641 centimeter square. This is the area of this smaller triangle. So to calculate the shaded region, area of shaded region, I will add the area of the two triangles. So shaded area will be the area of this triangle ARB, which is 19.1, plus the area of this triangle, smaller one, which is 0.641. So 19.1 plus 0.641. So this is 19.74. Up till three significant figures, this will be 19.7 centimeter square. So this is the total area of this shaded region in this rectangle, which is made up of these two triangles. So this was the last question of this paper.